Okay, I thought I would just start off with an easy one on a video in case, you get home. And actually, let me do number 7 here. We're going to try to do some in class, but I want to pick some other ones close to the beginning. I noticed all the videos were on towards the end. Let's say I've got this angle right here, and they call it theta. I drew it so little, I'm just going to make it a red dot here. It's a black dot, isn't it? Okay, let's try to make it a red dot. And it has a hypotenuse of 3, and then this leg is 1, and our instructions say find the exact values of the 6 trig functions of the angle theta for each of the triangles. Explain why the functions are the same. Okay, so we're going to have to go through the 6 trig functions for 2 different triangles. Now, I'm going to go ahead and address why these would be the same. Why should we expect them to be the same? If you notice, these 2 triangles are similar triangles. If I take the hypotenuse of the small one, multiply by 2, I get 6. If I take the leg of the small one, multiply by 2, I get 2, which is the leg on the other one. So similar triangles, if you remember, when we make fractions out of their sides, which that's exactly what trig ratios are, the fractions of the sides, they're going to reduce to the same values. That's one of the things about similar triangles. They have the same the ratios would be the same for all the different sides, so we should expect them to reduce down to the same things. So now they told us that, so we've kind of talked about why they might be the same. Let's go ahead and do the work quickly. If I look at this, if I think SOHCAHTOA, let's see, what do I have here? I have opposite and I have hypotenuse, so I know that the sine of that angle is going to be opposite over hypotenuse would be 1/3. And then when all the 6 trig functions, so that reciprocal would be cosecant theta, which would be 3/1. So that would be 3. And so we'll just kind of do them in the same order I'll just kind of write the spots we'll look at over here. All right, so now let's do the cosine. Now for cosine, I need adjacent over hypotenuse. And if you look back at numbers 1 and 3, what you can do to find that missing side is use the Pythagorean theorem. Let's call this missing side A, just because we don't know what it is, and I'll just say it's A for adjacent side. 1 squared plus A squared, and of course it's not going to pick it up, is it? 1 squared plus A squared is equal to 3 squared. So A squared is going to be, 3 squared is 9. If I subtract the 1 from both sides, I get A squared is 8. So A is the square root of 8. That happens to be 2 square roots of 2. Because 8 is 4 times 2, square root of 4 is 2. I bring that out, I got a square root of 2 left. So the adjacent side would be 2 square root of 2, and the hypotenuse would be 3. Okay, let's see. Oops, this should be cosecant, and this should be cosine theta. Okay, so now if I want the reciprocal of the cosine, it's going to be the secant. And so I'll flip that as 3 over 2 square roots of 2. But when I multiply by square root of 2 over square root of 2 to get rid of the radical, I get 3 square roots of 2. And on the bottom, I'd have 2 times 2 is 4. So it would be 3/4 square root of 2. Hopefully, if you can't read it, you can hear me say it, right? Now, the tangent of the function is going to be the sine over the cosine. So I also could go figure it out from the triangle. It would be opposite over adjacent, so might be easier to do it that way. Opposite over adjacent would be 1 over 2 square root of 2. But I got to get rid of the radical in the denominator, so I'll multiply by square root of 2 over square root of 2. That gives me square root of 2 over 2 times 2 is 4. Now, if I'm going to flip that, remember, it started out being 1 over 2 square root of 2. The only reason I had to do the radical was because had to do the square root of 2 over 2 is because the radical's in the denominator. But if I go back to that original value, which right here, 1 over 2 square root of 2, and I flip it, I just get 2 square roots of 2 over 1. So let's do that. Let's not flip 4 over square root of 2 and then have to go rationalize it. So we've got all our values. What we need to do over here is see that they're the same thing. We know that sine is opposite over hypotenuse. Let me try to write with a different color just so maybe it'll stand out. So that's going to be 2 over 6. And guess what? It reduces to 1/3, and they're the same. These are similar triangles. Their ratios should be the same, and all the trig functions are ratios of the sides. Okay. Now for cosine, it's adjacent over hypotenuse. I'm going to have to go do the Pythagorean theorem. 2 squared plus this a squared is equal to 6 squared. So your a squared would be basically 6 squared on the other side is 36. And then we would subtract the 4 that we get from 2 squared. A squared is 32. And again, we're not going to have a perfect square here. 16 times 2 is 32. So if I square root 32, the square root of 16 is 4. And then I would have a 2 left over on the inside. So the cosine here is going to be adjacent 4 square root of 2 over the hypotenuse, which is 6. And when you reduce it, that's 2 square roots of 2 over 3. So that's also the same. I forgot to flip the cosecant up here. If you flip 1 over 3 from the sine, you get the cosecant, which is 3 over 1. And if you look, so far so good. These are all coming out the same, aren't they? And again, we expect them to because they are similar triangles. As a matter of fact, what this is trying to kind of maybe build in your mind is that maybe if you had a situation like this, you could just go, they're all going to be similar, so the ratios are going to be the same, and so maybe even you go ahead and reduce the numbers down if you wanted to. You should get the same trig functions, as long as that's all you're doing with it is trig functions. All right, I need to do the secant here. Secant is the reciprocal of cosine, so I will just flip it. Let me flip this number. No, let me flip the reduced one. It would be 3 over 2 square roots of 2, but I gotta get the radical, rationalize, so I'm gonna multiply square root of 2 over 2. That's 3 square roots of 2 over 2 times square root of 2 times square root of 2 is 2. 2 times 2 makes 4. Again, we've still got all the same stuff. Tangent, I could put the sine over the cosine. I could put 1/3 over 2 square roots of 2 over 2. But since I already know this is 4 square roots of 2 on this side, I'm going to say it's a little easier not to have that. And again, I should have had theta on all these, shouldn't I? Every once in a while I forget it. So let's do opposite, which is 2 over adjacent, which is, wait a second, 4 square root of 2. Yeah, that's right. Okay. And then that would reduce to 1 over 2 square roots of 2. And if you look, this over here is what we had originally over here before we rationalized it. Again, it's going to rationalize the square root of 2 over 4, the same thing. But we're going to go, hey, we already did that work. Let's be smart and not redo it. And so my cotangent, what I'm going to do is flip this fraction, because I don't want to have to go rationalize the other thing. And remember, when I flip the thing that was needing rationalized before, it just becomes 2 square root of 2 over 1, which is 2 square root of 2. Everything's matching up here.